Hello, everyone. On behalf of the Southeast New England Program Network, welcome to our webinar today on green stormwater project construction oversight. My name is Tess Clark from the Syracuse University Environmental Finance Center. We are a SNP partner, and I'm happy to be assisting with logistics for today's program. In just a moment, I'll be handing things off to the amazing team at the Providence Stormwater Innovation Center. Before we get to that, there are a few logistics to keep in mind. So first, everyone will be on mute to ensure audio quality. You will be able to ask questions by typing them into the questions box on your GoToWebinar control panel. There will be a few opportunities where we will pause for questions, so please submit them at any time. Additionally, please take note of the handouts tab on the GoToWebinar control panel. You can actually download a copy of these slides for today, and you will also get a follow-up email from us after the webinar with a link to the recording and any other material that you may need. Additionally, if you'd like a certificate of attendance, you can request one directly from the SNP network by reaching out to Leah Soloway. Her contact information is on all the confirmation and reminder emails that you've received. Now for a little bit about the SNP network. You can see a map of the Southeast New England program region here. The SNP network's mission is to empower communities to achieve healthy watersheds, sustainable financing, and long-term climate resilience through management of stormwater and restoration projects. This webinar series is one of the ways that we strive to serve this region. And if you want to know more, you can check out snpnetwork.org. On that note, I'd like to hand things over to Ryan Kopp of the Providence Stormwater Innovation Center. Ryan, take it away.
Okay. Just wait for Brian's slides to come up.
Should just be a minute. Brian, if you click show my screen. Yep.
Okay, welcome everyone, and thank you for attending today's training on construction oversight of green stormwater infrastructure. My name is Ryan Kopp. I'm the stormwater coordinator here at the Providence Stormwater Innovation Center, and I'm gonna just give a quick brief overview about the Innovation Center, and then we will get straight to our presenters. Next slide, please. The Innovation Center, at least during normal times, is a place-based training center where our goal is to share information and knowledge with professionals in the industry about green infrastructure and about stormwater. As you can see on the map on the right there, there have been over 40 stormwater best management practices that have been implemented in Roger Williams Park to improve water quality in the ponds, but we also incorporate this high concentration of green infrastructure into many of our trainings. So people can get out in the field, get a firsthand look at a variety of different structures, see how they work, sometimes see how they don't work, and learn about what went right or what went wrong in the design, the construction, or the maintenance process. At least that's how it works when we're not in a pandemic. Now you get a webinar with some talking faces, a few pretty pictures, but you still get all the knowledge, so hang tight. We also want to better understand how these green infrastructures function, and so we are working with the University of New Hampshire and the University of Rhode Island to monitor some of these BMPs to see if their real-world performance matches what is being modeled and designed. Also part of this monitoring, we want to see what level of maintenance is required to keep these systems functioning. They've also installed continuous water quality monitoring equipment in the ponds to try to figure out if all these BMPs are actually changing water quality in the ponds like they're designed to do. And then all that data and information that is being collected from this research is incorporated into some of the different trainings that we host at the Innovation Center. And our last area of focus at the Innovation Center is to engage and educate the local community about stormwater and about green infrastructure and how the public can make a difference in their own homes. So we do things like we give public tours of the BMPs, give general talks about stormwater, put up signs in the park near the BMPs to explain what they are and what they do. We also participate in multiple volunteer monitoring programs to get neighbors from around the park involved in the different types of data collection that we are doing. And most recently, we held a stormwater focused arts festival where the artists created murals near some of the BMPs to kind of draw attention to them and raise awareness about stormwater and about water quality. So that's a brief overview of the Innovation Center. We've got a great group of presenters that have an immense amount of knowledge about stormwater management and construction oversight. So I will quickly introduce them and we'll get to the presentation. Next slide. Brian Burns is the Deputy Superintendent of the Providence Parks Department. He's a graduate of the University of Rhode Island with a degree in urban planning and resource development. He has over 30 years of construction experience, and he started with the Providence Parks Department in 2015 and now manages projects in over 120 parks around the city. Next slide, please. Lisa Richardson is a managing engineer in the environmental division at the Rhode Island Department of Transportation. She worked 25 years at the Rhode Island Department of Environmental Management in the Office of Water Resources, focusing on stormwater engineering and permitting. But she joined RIDOT in 2017 in the stormwater program, where she incorporates environmental strategies, flood mitigation, and water quality improvements in various transportation projects. Next slide, please. Heather Hamilton works in RIDOT's Natural Resource Unit and MS4 compliance program with a focus on stormwater construction issues. She has 10 years of experience with the state of Rhode Island in the environmental compliance and wetland science fields. She also has extensive education and outreach experience working with nonprofit and environmental science programs. Next slide, please. And Chris Shea is a senior project manager and stormwater practice leader at Wood Environmental in Providence. She has over 30 years of civil engineering experience in Rhode Island and around New England. And she most recently assisted the Providence Park Department in designing 27 of the stormwater projects in Roger Williams Park. Okay, and now that you know everything about us, we want to have a little poll, take a poll and know a little bit about your guys' backgrounds. So if you can take the time to submit your answers.
Yep, and I'm popping in to say it looks like we have about 68% of people have submitted a response. We're going to go ahead and give you a few more seconds. So I'm going to close the poll in 3, 2, and 1.
Okay, so it looks like pretty government dominated. So yeah, interesting. I will pass this over to Elisa now, and she will start off the presentation. Thank you.
Welcome. So one of the big changes that happens in stormwater is why stormwater and not drainage. Typical drainage design is just get that water away from the road as quickly as possible. Water causes problems with roadways. However, there are many reasons to to clean the water prior to discharging it into the river. Because we weren't doing that, and the DOTs in the past were just getting that water away out large pipes into streams. Almost 40% of our waterways do not meet water quality goals, and that's due to a lot of direct discharges into these waterways. So because of that, and because of the failure to meet our permits, there's a consent decree that was issued to the Department of Environment, DOT, and also a consent agreement to the City of Warwick and the City of Providence. So now we have monthly meetings, and we're being challenged and forced basically to treat this stormwater prior to discharge into our rivers and streams. Next slide. So there are 6 minimum measures that every municipality is required, large municipality is required to meet. And what we're going to be talking about today is the 4th minimum measure. This is a permit that is issued by the NPDES program, the Pollutant Discharge Elimination Program. And so we're going to be talking today about construction site stormwater management, very little, but mostly about this post-construction stormwater management. After the job is done, is the water getting cleaned prior to discharge into a river, stream, or pond or lake. Next slide. So what you're going to see today is really the building blocks of stormwater. You might hear terms like BMPs and STUs. They are pretty much the same thing. The state of Rhode Island calls it a best management practice, a BMP. EPA calls it a stormwater treatment unit, an STU. So if you hear these terms back and forth, they pretty much mean the same thing. What we're asking for is, or what is required is building a unit that will accept water. If you see on the far right-hand side, there's always some kind of an inlet. So water has to get into this unit. And then it is pre-treated, which means that we're trying to drop the sand and solids and large solids out of the unit, out of the water stream, the stormwater. And then there's usually some kind of a weir or overflow or some way for the cleaner water without all the sand to go into, and most of the time infiltrate. And then if this system gets overwhelmed, there's always an overflow. So if you look on the left-hand side, you'll see there's a curb inlet, and then you'll see there's some paving stones for pre-treatment. Then there's a weir, and then there's this bioretention system that is supposed to infiltrate the water into the ground and get it away. It will be away from the road, but it needs to get into the ground and out of the rivers and streams directly. But then if that does get overwhelmed, it's going to go into that overflow. You see the grate on there. And so the DOT is required to spend $10 million over 10 years to maintain these systems, to upgrade these systems, to install these systems. And so it is absolutely critical that they are built correctly. And that's why we're really doing this today. So I'm going to hand it off to Brian now, our expert in construction.
Lisa, thank you, and Ryan, thank you for the introduction. Tess, thank you for supporting us on this presentation today. Hello, everyone. I'm Brian Burns, and that was a great explanation of stormwater, and you're going to find those 4 elements in almost every stormwater site or BMP that you're going to be involved in. So it's pretty simple. Today, we're going to talk about pre-construction, which is almost just as important, if not more important, than the construction itself. The construction aspects, and then lessons learned, which we should always do. We should always look at every project at the end, what we did right, what we did wrong. And I think that's a big part of what the Stormwater Center is doing now. So for pre-construction, we're going to talk about the contract documents, the plan set and specifications, pre-construction meetings, existing conditions where most of your change orders end up coming out of, not documenting existing conditions properly, the intent of the design, the site prep, and the erosion controls. So we'll start with that pre-construction meeting. First and foremost, I see most of the mistakes made in our construction projects here when plans that are issued for construction are not on the site. So you as a contractor, you're bidding plans for bid. There could be alternates, there could be different conditions that exist that change those plans prior to construction. Many times I've gone to the site, we stamp our plans for construction so that everyone there knows those are the correct plans, they're dated, and more often than not, I see the wrong plans on site. And that can cost the contractor money, the owner money. It's a big problem. So existing conditions, photographs, and the restrictions. You know, like I said before, that's where all the change orders come from. So if you haven't documented what you have there, you're going to be hitting utility lines, elevations are going to be incorrect. And dig safe should always be contacted. And then in addition to that, if you have electricians that work for you, if you have entities that are involved in whatever site you're at, please get them involved, ask them for the information that they have. A lot of times the people that maintain these sites have the best information about what's there. So really do your research before you put the shovel in the ground. And then as always, you should be aware of any special conditions, permits, NEPA restrictions. At that point, you want to identify the project team. The contractor, the owner, the engineer, all knows who needs to know who to go to. And there should be one sole project manager that's responsible for everything that takes place on that site. And that should be the last person to make the decision. Talk up to the contractor about the scheduled inspections. You want to inspect subgrades, you want to inspect wears, and then in particular, you want to do inspections at post-storm. So if there's a big storm event, you want to make sure you get there, make sure the erosion control's in place, make sure everything's all set, and see if what you're doing is actually working. Another important thing is stockpile areas. Always be concerned about compaction and where the heavy equipment drives. You can't compact areas, especially in a phased project, put materials down that eventually become an area that needs infiltration. So reviewing the intent of the design and the specific elements is very important. And I'd like to invite Chris Shea from Wood Environmental to talk a little bit about that.
Yes, good afternoon or good morning. I can't stress enough the importance of a pre-construction meeting, kickoff meeting with the owner or operator of the facility, as well as the contractor that will be constructing the work. And it's important to have your designer lead the design side of the project, whether that's a landscape architect or a civil engineer. I think I liken it to understanding a jigsaw puzzle. If you don't have the box cover and you don't know what the final plan is for all those pieces, it's really hard to put a jigsaw puzzle together. And I think it's valuable for a contractor to understand the components that Lisa went over earlier, the why we have an inlet control, whether that takes a portion or all of the flow, what the first cell in that system is for to remove the sediments, and why the weir that holds that water back to settle out the heavy suspended solids needs to be at the design elevation. And probably most importantly, not only understanding the design, but understanding the goal of the assignment, and becoming a partner and making sure that these, understanding that this is a value to all of us, to families, to the contractors' families, to all of us, in clean water throughout wherever the project is located.
Thank you, Chris. So after the pre-construction meeting and you get underway and you put a shovel in the ground, you need to do ongoing site reviews. So again, the construction set, very, very important. I often ask the contractor to look at his set of plans, so I'm not carrying 30 sets of plans in my truck. We also utilize iPads and your electronic equipment to keep those plans and maybe keep your truck a little cleaner. Construction details. You got to know what the assemblies are. So you could have a infiltration basin that's got layers of different types of sandstone and media. You need to know what it's supposed to look like when it's done so that you can make sure it's done properly. A lot of times the honor system is in place on these construction projects, and with reputable contractors that can be fine, but you need to know what you're looking at, and you need to know that those materials need to be kept separate. So most important in these types of sites, which are usually earthwork projects, a construction entrance. Make sure that it's maintained as this stone construction entrance, bottom picture on the left. It's pretty clean right there, but as the site goes and we get rainstorms, that starts to get mucked up. And if that stone is not removing the debris from the tires, that debris will end up on the roadway, which ends up in a catch basin, which ends up back in probably the waterway you're trying to protect. So you got to make sure that that's maintained. And locate the stockpile areas like we talked about before. Make sure they're not stockpiling areas and causing compaction in areas that you're going to need infiltration in later. When it comes to trees, you'll have trees typically on a site that are designated for removal and trees that are indicated to stay. We've used ribbons in the past. We found that if trees are supposed to come out, marking them with paint is a permanent mark, and we'll make sure that the right trees are getting pulled. So we ribbon trees to stay. We mark trees to go. And another part, material submittals. So you're managing 5, 6 projects. You've got a lot of different things going on. There's some real off-the-cuff things that you can do to make sure that the materials being put in properly and the right materials arriving. So we submit on shop drawings. So you need to have access to the shop drawings and submittals, because that's going to tell you the products that have been approved for this project. And it's an easy way to confirm compliance. If you have that data, it's going to tell you what the product is, where it's coming from, and that's easily verifiable when you're out in the middle of the site. The test data that you receive, and sometimes it's done prior to a project manager getting involved, needs to be current. So you get a loom sample, a test on the loom, and it's 3 years old. That loom is not the loom that's going to be coming to your site. So those test data, that test data needs to be current and accurate. And it needs to be approved before it gets there. And then those submittals will tell you who the vendor is. So if you have a loom sample that you approved from ABC gravel yard, when the driver pulls in with the loom, walk up to him, ask him for his slip. They're going to get a slip when they leave. If it says XYZ gravel yard, you know that material is not the right material. So it's a very easy way without getting into details of submittal of verifying that the materials that are coming there are correct. And so packing slips, bills of ladings. I always have my iPad with me that gives me a camera. I take thousands of pictures on the sites that we manage. I'll take a picture, bottom right, of the actual product label, and then I can refer to it later if we need to replace those cobbles in this case, or I can make sure, looking at the submittal, that that's the one that was specified and therefore the one that arrives. Most importantly, in stormwater elements is the soil media. It is engineered specifically for the task that it's been drawn for. If it's not the right media, and or if that media has been compacted, it is not going to function, and therefore your practice will not function. So you can't look at a pile of soil media and tell if it's the correct one or not. You need to see a slip from a vendor that identifies the product and identifies where it came from. There's no other way to do it. You don't have the equipment to do that. Another easy way is with samples. You can have samples of granite for a wear, you could have, which is hardscape materials. We ask for 5-gallon buckets for bulk material, like that soil media we were just talking about. And any plants that come to your site should have the tag on them. Sometimes in some nurseries, they'll tag 1 or 2, put a certain ribbon with dots on it. And if those plants come in with that dotted ribbon, then you can assume that it's the correct variety. But depending on the time of year, it may not be leafed out. It's difficult to tell if those plants are the correct plants. So you should require that those tags come on the plant when they get to the site, and then also make sure that they are removed once you've approved the planting and we're at a warranty or punch list issue. Removal of tags should always be on your punch list if they're still in place. So existing conditions and restrictions, we're going to ask Heather Hamilton from DOT to talk a little bit about this. Heather. Oh,
actually, Brian, this is that's coming in a few slides.
I'm going to talk about this. That's right. So soil performance data should always precede construction. So you may be doing an infiltration basin and you may be putting 18 inches of material onto existing subgrade. If the test pits, core samples have not been done, the design only works to the end of what you put in or the improvements that you made. It doesn't take into consideration the soil that's there. So again, may not be something a project manager is looking at, but you've got to know that where you're installing these things, it's going to work. There's stormwater management plans, and we're going to talk a little bit about that later. Soil erosion plans. You need to know the restrictions, and you need to know what this contractor is allowed to do. This is a great drawing from one of the projects we reviewed in, I think it's in North Kingston. So that shows you exactly what South Carolina looks like. So it tells you exactly what you need to do. It identifies it very clearly. So having this on your iPad, having this in your truck is very important. There could also be other things like easements, environmental land use restrictions, which can get very complicated, could be very site-specific remedial action work plans, and then permits from DEM, and then the requirements of those things. So a lot of this is done before you get involved, but you need to know that. You need to know what it is because you're responsible as the owner of the property for the containment of the soils that are on your site. The contractor is also responsible, and Rhode Island DOT is working to put more responsibility on the contractor because they're the ones that are failing to provide it. But in the end, you as the owner are responsible for any movement of soil into an environmental area, unsafe environmental area. Also with existing conditions, if at minimum you need to locate the elements that you're tying into. So existing catch basins can be retrofitted. On the right-hand side, they show a doghouse. So basically, in its most basic form, a doghouse is a structure that's dropped onto an existing pipe most of the time. Sometimes the pipe's new. And the elevation's critical. We deal with this all the time. Elevations are slightly off. I mean, 6 inches can make a big difference when it comes to stormwater. So everything has to be accurate. So hopefully your consultant has done their due diligence. and they have provided you with the correct information. You don't want an open road or an open highway and find out that your pipe is 8 inches higher than it should have been or lower. So we can talk about materials, we can talk about where to put it, but the bottom line is, what are we looking to do here? And I thought Elisa really captured it when she talked earlier, but you as a project manager need to know how this thing's supposed to work. It's not always intuitive. And we're going to talk about catch basins on the roadway that are designed to take all of the water, and then there's catch basins that are designed not to take all water. Most contractors, when they put in a drain basin, they make sure it's in the lowest spot. Well, that's not always the case. So you need to know, because what's intuitive to you and what a contractor may suggest to you, hey, you know what? It's actually lower 30 feet down the road. Why don't we change this all over and go 30 feet down the road? There could be a design intent not to have it in the lowest spot. So you need to know that. So at that pre-construction meeting, I think Chris talked about it, you want to really get down dirty about how this thing's supposed to work, where the water's supposed to come in, those 4 basic elements. How's the sediment coming out, how it's getting filtered, and if it overflows, where it's going. So, and that's basically it. This is pretty simple stuff. Get the water and sediment into the practice, remove the sediment, and then contain it in a place where it can be removed mechanically. Slow down the water, because when you slow the water down, the sediment tends to drop out. That's how we get the sediment removal. Direct it to the infiltration area. Stop stormwater from entering your waterways on filter, and have an overflow in place for larger storms to prevent damage. Hopefully, or the easiest thing to do is have that overflow be part of the existing infrastructure, so that you're not spending a lot of money for one, and you're not reinventing the wheel in this particular site. If there was a pipe that brought it to your waterway directly, if you can utilize that for your overflow, that's going to be the most economical way to do it. So here now we're going to get more into the erosion controls and some of the aspects of those plans we talked about. So I'm going to ask Heather Hamilton to take it from here.
Thanks, Brian. All right, for site preparation, most of this will be guided by your site plans and your stormwater pollution prevention plan, also known as a SWIP, or Soil Erosion and Sediment Control Plan, the SESC. Your site prep is going to consist of everything from erosion and sediment controls, tree protection, creating construction access points for your equipment, where you're going to store and protect your stockpiles, and your overall project layout. Note that also important here is the protection of the location of your stormwater treatment BMP. Simple snow fencing works well to demonstrate that the area should be off limits to vehicles and storage, and we'll talk a little bit more about that later. All right. We're probably all familiar with the basic erosion and sediment control measures for construction, from filter socks pictured here in green to the inlet protection in the form of silt sacks shown below. The tree protection is also important, not only for trees above ground, but for its roots below. And that's why many times you will be asked to install some sort of fencing at the drip line to prevent equipment from damaging the roots and ultimately killing off those trees you want to protect. You'll see an example of this in the background of the top picture, and here they use silt fencing. Next slide, please. So key points here are to make sure that your BMPs are properly installed prior to any earth disturbance, and that they're installed per the manufacturer's instructions or your specifications. We are only preventing pollution from reaching our waterways here. We also want to protect and prevent our stormwater treatment BMPs from becoming clogged with sediment and debris prior to them being completed. So you want to make sure that you have enough controls for the life of your project, and always plan to have some on site for emergencies. Next slide, please. All right, so at this point, you've memorized your stormwater pollution prevention plan, you've properly installed all your BMPs, but that's not where the story ends, however. We don't get to set it and forget it here. To prevent pollution from entering our waterways, regular SWIP inspections must be conducted to ensure that all of our BMPs are functioning properly and that any areas requiring maintenance are called out and fixed, which the contractors are responsible for. So this includes your construction entrances as well. In Rhode Island at DOT, even if we disturb less than an acre, we still require weekly and post-storm inspections. So overall, it's in the owner's and contractor's best interest to maintain the controls to avoid costly repairs and possible reconstruction of your final product. An eroding stormwater BMP full of sediment when it's completed doesn't do anyone good. Next slide. And with that, I will turn it back to Brian to finish with your site layout.
Thank you, Heather. So site layout, really important. We look at a lot of plans, and more importantly, your stakeholders, people that are in your organization that may not be as familiar with construction as you are. If they're involved in the project, it's a good idea to get some layout done. And we use the old-fashioned way. There's total stations that assist in this, and GIS, a lot of electronic equipment for layout. But in the end, there's going to be a grade stake showing elevations with a ribbon for the most part. And I would suggest that you get out there prior to the installation starting and outline the major areas. You marking paint on the ground, stakes with ribbons. That's helpful to you because we look at a lot of plans. We don't realize, oh, wait a minute, that thing's going to go right across a path that everyone uses every day, and you didn't pick it up on the drawing because maybe the path was an existing path and it was lighter than the rest of the drawing, and you just didn't pick it up. So by doing this, you avoid problems later. It's real easy to change design before the contractor started. Once the shovel goes in the ground, those costs escalate dramatically. So locate those things so that you can walk it with the consultant, with the contractor, and somebody else in your organization may involve in the project so that you get a good feeling of what you're doing and what this is going to look like in the end. And they can be deceiving. So avoid the change orders and get it done before they start digging it. If you're going to change the design, let's say there is a walkway that's impacted by an infiltration basin and you want to change it, you don't want that infiltration impacting that sidewalk. If you're going to change a design, the most important thing in stormwater is not changing the size. So if it's a 10,000 square foot infiltration basin at a certain elevation, you can change the configuration, but you can't change the size. So you can't just chop off that section that goes across the walkway and drop it down to 8,000. If it's scheduled for 10,000, it needs to be 10,000, otherwise it's not going to function properly. Mock-ups. So we use granite curbing for wares. Have them do mock-ups on site. You can either do them in a different location on the site if you don't want it to impact the excavation, or if possible, prior to them completing the work, have a mock-up done in place. Then you actually get to see what it looks like in place, and you can approve it and have them continue forward. These are things that's going to save you money in the long run and make sure the project stays on schedule and on time. When you do your site visits, I schedule a weekly visit at the same day, same time every week. And then I show up randomly to my construction sites throughout the week. And you need to do that, not that you're checking up on the contractor, which you should be, and you are, but the contractor knows what the plan says and he knows what he's supposed to do. He bid on it, he's got that. But when you get to these sites and you look around, you may be reminded of other things. Oh, you know what, we do an outdoor movie over here. If we're moving, okay, there's a problem there. So the contractor may have no idea that outdoor movies are being put on this grass area out in front of your building, but you do. And you got a lot of projects, you got a lot of things going on. Just physically getting out there and walking it reminds you of other things that may be taking place that they don't know about. Photographs. Again, I take thousands of photographs. It can help you later on if there's some type of litigation. It gives you the time frame for the work. You may say you get a call that somebody fell into the stormwater thing in January, and you can provide documents that say the construction project wasn't even take place at that time. And then it also tells you that the work was done correctly. And then, particularly for utilities, if they're installing new pipes, installing new lines, taking pictures, you'll always have an as-built to back up on, but a picture is 1,000 words. So look at that picture, you can see exactly where it is, line yourself up with a landmark that's going to remain when you take your picture of a pipe, so you can kind of get an idea where it is. It avoids conflicts later, and it protects you. And sometimes contractors give me a look when I'm out there taking pictures, but it protects them as well. Like I said, we get calls for lawsuits, somebody tripped and fell, and we've saved more than one contractor from being sued themselves because we documented when their work was taking place. So inspection reports are something that you can get from your consultant. They'll come out, and if you should make sure they have contract administration in their contract if that's what your organization does. They'll come out, be it weekly, which is typically what we do. They'll do a full inspection when they're there. They'll take pictures. They'll document specific items that need to be changed or replaced. And what this does is a punch list is always performed at the end of a site project. So by having weekly meetings and identifying deficiencies as you go along, the contractor can correct those as he's going along. So we find that our punch lists are very small because we are regularly out on the site, we're directing them as they go, and then you can shut down projects. The longest part of the project is the last 10%, just trying to get all these things done. This kind of reduces that and gets you the right product, and the contractor is more agreeable to be doing it because he's there working versus coming back later and fixing something that you should have picked up on weeks ago. Always have an updated set of plans. The contractor should maintain them on the site. And then in the end, we're going to ask for as-built. If you don't, you should be. And we here in the City of Providence require that as-built are done by AutoCAD, and we have just recently required that the consultant provide the final as-built to us versus the contractor. So while the contractor is mocking up that set of plans and they're identifying distances and locations and changes, he would then theoretically send those plans to the engineer and compensate them some way. And then the engineer would incorporate it into the as-built that the AutoCAD drawings that they already have. So I get a really accurate, and part of their scope of work is to verify the as-built. I get a real accurate set of as-built in a format that I can use for either the next project or compliance with a permit or otherwise. So it's very valuable. And getting that set of drawings that's covered in coffee and there's pencil marks and somebody's phone number written on them, not as useful as a plan that comes in an AutoCAD format that you can use with the design equipment that you have. So this construction drawing should be relayed back to the as-built. Means and methods. So you're going to tell somebody how much stone there is, how wide a swale's got to be, and that's kind of where your responsibility ends. The means and methods, how the contractor brings that stone to the site, how the contractor excavates that material. Otherwise, I mean, regardless of you identifying compaction areas and making sure they're not driving over critical items, it's up to the contractor to figure out how to get this project done. We tell them what we want, but we don't tell them how to do it. And safety should always be the first thing. This is the Japanese garden in Roger Williams Park, and they were installing a new weir, and this is the method they came up with. I didn't sleep much during this week that we were doing this, but they're cantilevered over the waterway on large sandbags with a mini excavator, and it was sketchy. So as long as you're confirming that nobody's getting hurt, but ultimately it's the responsibility of the contractor to make sure that his employees are safe and that the methods that he uses are correct. So you've got to be conscious of it. And then we have to protect our work. So the level of protection should be equal to the level of danger. So we all talk about temporary fence. You can install chain link fencing around these sites to make sure people don't walk in. I just love that my guys came up with this. We had a seal statue that was being, had a ribbon cutting. It was a big event, was much anticipated. And putting a plywood box over it in a urban area, doesn't always last, but we find danger high voltage always works. Nobody really wants to touch that, but that's what it's protected. I just like that photo. So, okay, the project's ongoing. We're thinking that the contractor's doing what he's supposed to be doing, and hopefully he is. How do you verify it? So oftentimes, even when your consultant doesn't come out, they're not shooting grades. They're not looking at the flow of the water. They're making sure that the products that are supposed to be used are being used and they're being installed the proper way. But there's a limit to what they can do on a 1-hour site visit weekly. So when it comes to stormwater, the best way to determine if these things are working is during construction. If you get a rain event, and if you look at the photo on the top left, our stormwater element is on the left-hand side, and there's a scupper you can see if you line yourself up with the backhoe, and our water is running down the right-hand side of the roadway. In this particular case, we had two contractors.
Water doesn't lie, right, Brian?
What's that?
Water doesn't lie, right?
Water does not lie. So in this particular case, it was compounded by the fact that we had a roadwork contractor doing the work inside the curb lines and a stormwater contractor working outside the curb lines. So the roadwork contractor didn't catch that this bike lane needed to be sloped the other way when he installed the curb. So we ended up working it out, but I would have never known that. Optical illusion looked to me like the slopes were correct, but when I saw this rainstorm came, I took the picture, and everybody knows that that's not installed correctly. So it's up to you to make sure they work, and paying attention and doing it as the construction goes on is an easy way to determine if this stuff being correct. Now, it's the contractor's responsibility to do it right, but ultimately you want to make sure it works anyway. You can request verification from the contractor if you think something's not right, and particularly when you get into wears, and we're going to talk about diversion structures later, inches make a difference. You know, if a wear is 2 to 3 inches off, it could affect a lot of performance. So it's not easy to see. So you just have to watch how it's working. Hopefully your contractor hasn't demobilized, you still got them there. And you can use a flood test too. Sometimes we'll pull a fire hose out, we'll drop it into the street, and if we got a dry season like we did, that tells us where it's going. So the contractor needs to make sure it's done right. They're going to do it at their own cost. It wasn't my fault that they didn't install that curb at the right elevation. And because we caught it, and this is just binder, this is not top coat, by the way. So we ripped out the binder, repaved it, and it is no problem. But if I didn't know that that water was supposed to go on the left-hand side, I wouldn't have picked this up. So you need to know what it's supposed to do. And then infiltration basins, we'll talk about those a little bit in a little bit, but you can have water in an infiltration basin. That doesn't mean that it's not working, you know, and we'll talk about that later. So that is a full infiltration basin, and that infiltration basin is a sand filter, and it works great. So I'm going to ask Heather to talk a little bit about this, about some of the things she saw at a DOT job that she did. Heather, you want to weigh in on this a little bit?
Yeah, thanks, Brian. So Brian was talking about the importance of verifying work as you go. This is a perfect example of an unfortunate incident where that didn't happen, because this is at the final inspection. So this is a situation where we have a basic unit where water would enter the forebay off the street and allow some settlement to settle out, go over the weir, which if you top photo is the lighter colored granite there in the middle, that's the weir. So it's supposed to go over the weir and then into an infiltration area for additional treatment. However, in this case, the unit was constructed with the weir either lower than the infiltration area, or they included extra soils and other materials in the infiltration area. So if you look at the plan, you can see some differences. There was, to the left of the pre-treatment weir, there was gravel that was to be placed that was missing in the actual biobasin on the side of the road. So that gravel was missing. And then if you notice, the amended soil mix is supposed to be quite a bit lower than the weir to provide for capacity to accept some stormwater and then allow it to infiltrate. But as the photos show, the soil, the mulch, the plants are all higher than the weir, and we know that water doesn't travel uphill very well. So this situation, you know, is going to end up where we have water going into the forebay, not being able to infiltrate, and then going back out into the road, potentially flooding the road, and then eventually directly entering the catch basin, which will then enter into the waterway down the road. So here's a perfect example where it's not a very difficult unit that we're constructing here, but if there was more understanding of the system's purpose and the components with some additional oversight, we would have had a better functioning system at the end. So just to, you know, repeat what Brian said over and over again, it's so important to be out there, to be overseeing these, to ask questions if you see something that doesn't make sense, and to make sure that the people who are constructing these have a good understanding of what is supposed to happen when it rains.
All right, thank you, Heather. I think we are going to take our second poll at this point. Tess? We'll give you a couple minutes to weigh in on those questions.
So I'll just jump in and quickly say it looks like about 50% of people have submitted a response. If you're not quite sure, you can always select other. And for the sake of time, I'm going to go ahead and close the poll in 3, 2, and 1. And here are the results.
Thank you, Tess. So now we're going to get into the elements of the stormwater sites a little deeper. There's 3 basic areas: pre-treatment, treatment and infiltration, and then slope stabilization. And we'll talk a little bit about all of those, but I just want to preface it by saying the top left photo is a forebay, and a lot of you may not have seen a forebay that's made of pavers. We have, here in Roger Williams Park, have developed a forebay that is made of either permeable or impermeable pavers. So a lot of times this is your riprap stone. It's the same thing. It could be river rock, but you'll see a lot of pictures that show pavers, which is something you may not be used to. So I just want to make sure we were all aware of that. It's all the same thing. So inlets. So there's 2 different types, well, there's many different types of inlets, but there's 2 different intents from those. But basically what it does is allows water into the BMP, the best management practices. The design will determine how much of the water is going in there. So not all inlets are intended to take all the water. So you as a project manager need to know low flow utilizes the roadway as an overflow, and it usually goes to an existing catch basin down the road. A inlet that takes all the flow forces all of the water into the practice and then relies on the overflow pipe in the infiltration basin to remove the excess water. So I'd like to ask Chris to talk a little bit about that and her opinion on that. Chris?
So there's 2 schools of thought on the low flow versus high flow practice. The regulations, the DEM regulations, and actually most Northeast communities require that we treat what's called the first flush, or 1 inch of runoff. And that actually covers probably 90% of all storms that occur in annually. Higher storms, 2-year storm, 10-year, 25, 100. By the time the so-called first flush is through, that's where your dirtiest, most contaminated stormwater is coming from. That's where you have road sanding's been done, salting, petroleum products that have dripped off cars. These are all removed during that first flush of a storm. So it's definitely critically important to design your practice to treat that 1 inch of runoff. And as Brian said, typically those, as is shown in the top photo showing the low flow, is a little curb cut. It's intended to just take a small amount of water. When the bigger storms hit, we wanted to choke down that entry point and allow the water to continue to flow along the gutter line and to a standard closed drainage system or other outflow. In the lower photograph, you see more of the high flow. This is just an open curb cut. It takes all of the stormwater. It's not a bypass. And so this will treat the first flush, but you also have to deal with a lot more stormwater coming into the practice. So the important thing here is acknowledging that you're going to have higher velocities, higher flows, and you have a lot more robust riprap or other mechanisms to slow down the velocity. Those would be required in the high flow practices. And I personally like the low flow because it is just a small amount of water. You can control it better. You don't have a lot of the issues during construction with erosion, and you don't have a lot of issues in the long term with trying to keep these areas from eroding due to high velocity.
All right, thank you, Chris. Traditionally, you'd see scuppers. We call them roadway scuppers. So basically, an inlet can come into a basin and get piped to a stormwater practice, or it can sheet flow off the roadway. So here in Roger Williams Park, on the top left was a scupper that I constructed back when I was a contractor versus working here at the park. We basically took some insulation, we made a void underneath the concrete sidewalk, and then pulled the insulation out and the foam insulation out, and the water now runs underneath that sidewalk, suspended by the 6 inches of concrete on top. Oftentimes you may have a diversion structure top right. That's a structure that was already in place, and then we just added a walkway on either side of it. We retrofitted the structure and then put the practice in. Bottom left and right, this is kind of what we've come down to. We have a lot of areas in the park where sidewalks, and throughout our park system, where sidewalks, we want to do sheet flow, take a catch basin offline. we use this drain base, this trench drain, and basically we found that on the left-hand side, we encompassed it with concrete all the way around versus the right-hand side where we let it just expose itself at the end. That this has been removed a couple times on us, but so we learn lessons that way too. But it can be done, and oftentimes I would see a sidewalk that's stopped and riprap will be put through it for a scupper, and you're forcing these people to walk over the riprap, which is not a good situation. So how do you get it off the roadway when it comes to sheet flow? We've used 2-foot concrete returns, top left, radius curbs, top right, transition curbs, 6-foot transitions, 3-foot transitions. And when you're using those transitions, we had a lot of problems with the gap between the ends of the transitions. So you have several things you can do. You can put the concrete curb in flush with that. That's a great way to do it. You could carry the asphalt pavement from the street in, or if there's a pavement on the inside in your forebay, you can carry the forebay out. The critical thing is that there's no lip here on the inlet. Especially when you have a scupper like the left-hand side, where you're asking water to take a left-hand turn off the road, you've got to make sure it's going to make it, and you got to make sure it's not impeded. So there's some considerations you got to look at. It has to be done correctly, and you want to make sure that those pavements carry through or install that concrete curb. So diversion structures, retrofitting existing catch basin structures in a roadway. They could be along the side, but it does the same thing as an inlet. It takes all of the water typically, the low and high, and then there's a wear wall inside that as the water flows, the first flush or the low flowing gets directed one way, and then when the volume increases, it just overtops that wear and goes directly out to your overflow, so that you're not pushing a lot of water through these stormwater practices that can wipe out some of the elements that you install. Again, we keep saying it, it's critical that these weirs are installed at the exact right height. If you're not doing that, you end up bypassing the structure rather than pushing the amount of water you want to it. The good thing about these diversion structures is if you have a vac truck, if you had a clamshell truck, you can get there, remove the sediment in the bottom of this basin, and then you don't have to get into getting into the practice to remove the sediment. So there are advantages to some of these things, and I think some of the old school thought is that's the easiest way to remove the sediment, and it can be. So we've learned some lessons here. I think the top left, you'll see that there's a catch basin that was installed right in front of the inlet. So there's probably not a lot of water that's going to make its way over this catch basin grate and into this stormwater element. So you got to be careful. I'm not sure how this one happened, but you got to make sure that your inlet is performing properly. Top right this is river rock, which we will never install again in Roger Williams Park. My issue with river rock, it removes sediment really well. It's typically installed at about a 12-inch depth, but you have to wait till 12 inches of sediment have packed that river rock before your maintenance crews decide to remove that sediment. So that's one of the main reasons why we went to pavers. The pavers show the sediment as soon as it enters in there. So there's a lot of maintenance involved with those river rock sites. The other problem with inlets is during construction, you have to take them offline. On the bottom left picture here, you'll see that this was blown out by a big storm event, and because it was a vegetated inlet, we had erosion control matting and seed, and it's tough. So if your consultant can do it, this is a catch basin that's installed right here in front of the inlet, and we put a cover on it instead of the grate that was there. There was an existing pipe here that went out to the waterways. If you can keep that grate open while this material is setting up and the grass is growing, that's your best case. And then once the grass is established and the fabric is secure, you put that cover on there, you start directing it in, and that pipe just gets abandoned in place. So that's a great way to look at it. If your consultant can find a way for you to do that when you're not digging or excavating near that pipe, that would be good. The last one on the right-hand side, the low and high flow came in. This was a berm that was installed. The water was to flow in, hit that berm, and make its way through the infiltration area. Because of people walking on this berm and unpermitted use, this elevation changed, and you can see that now the water comes in, flows across that berm and into the water. So you've got to pay attention to what's happening in the structures down the line. And so this is what we do. We try and take them offline. And Elisa has a situation she dealt with. Elisa, I'm going to ask you to talk about taking structures offline during construction.
Yeah, thanks, Brian. So I just wanted to remind folks that you can ask questions in the chat, and as panelists, we'll get to that if there's time at the end. Most likely will be. So just a reminder there. In this top picture on the left, we were building a stormwater treatment unit. It's a retrofit of an existing catch basin. The corrugated smaller pipe on the right-hand side is the pipe that goes to the stormwater treatment unit. This unit, between the entire project, was about $200,000. We were doing our regular inspections, and the pipe on the left is the pipe that goes directly to the river. And so they're both at about the same elevation. We had to do some funky things there. Every 1/10 of a foot, every inch counts when you're dealing with flow diversion. It's incredibly important. And we opened it up and there was no cap. And so we were looking at it and just trying to, like, something's wrong, scratching our heads. It's just such a tiny detail. It was a $10 detail in this design. And there was no cap on it, which means the water was just going directly out to the river and not going into the stormwater treatment unit. And so in this design, that overflow on the far left is where the overflow water in the first flush is supposed to go off to the right and into the stormwater treatment unit. So we had to talk to the contractor, like, we had to go and inspect that. It took him a month and a half to get that cap on there. He ordered it a couple of different times, and oh yeah, I forgot. And it was the $10 thing that just made all the difference between this unit working and not working. And so what we needed to do was put a cap on the stormwater treatment unit until it was fully stabilized, and then take that off, and then put the cap on the one that went directly to the river. So these are just really fine points, but it just goes back to even having the designer on site once in a while to check out and make sure that this is working properly. And Brian, I really like the fact that you're requiring AutoCAD files for as-builts at the end. That's something that we're trying to incorporate at the DOT as well, and they are a part of every contract. As-builts are a part of every contract, and they are required by the consent decree. And then EPA, we report all of this to EPA, and they look at what was the design volume and what was the design treatment, and then they look at what actually was built. And so if we are continuing to not build as designed or get the same amount of treatment as designed, it's going to cost the state hundreds and hundreds of thousands of dollars more in retrofits and more designs and more treatment units. So Chris, I think this bottom picture is you, right? Is that, because yeah. So thank you, Brian.
Yep. Chris, you want to weigh in on the bottom picture?
Sure. We'll talk about our errors on the Roger Williams Park project. This is one of the things where I say it's very difficult during construction. You really have to think about how to divert the stormwater away from the practice while the practice is being constructed and while you're hoping for vegetation to establish. I think once the final design incorporates all of the anticipated velocities, and engineers calculate and determine what type of inlet devices, whether it's an erosion control blanket, riprap, paved waterway, whatever it might be. The engineers calculated anticipated velocities and designed the final structure to, over the long term, function properly. The problem is always during construction, and how in the case, I think in this particular case, this was at a low point. So it wasn't just a diversion, and we couldn't just sandbag it off and watch the water travel down to the nearby catch basin. This was it. This was the low point. And as Brian had mentioned, had we left the catch basin in place and instructed the contractor to leave that catch basin open, we wouldn't have had the problems that occurred. So what we had here was sandbagging the opening to prevent the water from, which was happening before the sandbags, that inlet, that was an erosion control blanket solution. The reason why we used that was because it's a park. I prefer using natural looking materials over riprap if I can do it. And the erosion control fabric in this case also wasn't installed properly. And so the combination of the fact that it was at a low point and it was eroding, we put the sandbags in place to hopefully allow the practice to stabilize and have the vegetation grow. And instead we got a heavy storm that came in, and it had nowhere to go but over the curbing, and it ended up causing problems and eroding out the entire embankment on the side of the curbing. So lesson learned, really evaluate prior to construction and talk to the contractor about the order in which things need to be done. So maintain, if there's a catch basin, great there, leave it in place. You can have the sandbag, and the practice can be established. And then the last thing that they do is replace the grate with a cover.
So, but Chris redeemed herself, and we came up in our lessons learned meeting. We now take that erosion control fabric and put it down in the inlet. If you can picture going towards the inlet from the slope, we put that down at least 3 feet. Then we put the gravel on top of that, and the balance of the fabric goes into the roadway as you're doing this. The gravel gets put down, then the loom gets put down, and then the fabric is folded back. So now there's not an edge that can be pulled up when that water comes through that inlet, because the fabric's being held down by the weight of the gravel and the loom. So we've done that. In addition, we double the number of staples that the manufacturer requires in that inlet area. And that's something you need to be aware of, because if you're referring to a submittal, it'll say 3 feet on center. We're putting them in 1 feet on center in that small area. With riprap stone, you want to make sure your filter fabric, and we're not always using filter fabric now, but your stone, if there is a layer behind it, or the gravel stone, extends beyond the footprint of the inlet, because what will happen is you'll start to get erosion in higher events along that riprap stone on the grass area itself. So you want to make sure that stone extends far beyond where a larger event would take the loom out. So forebays and weirs. So the sediment comes in, drops in the forebay, then goes through a weir as with the sediment being dropped out. So this is what we were talking about earlier. The traditional way, bottom photo, is a river rock, it's a riprap, and the sediment gets embedded in that. We're using permeable pavers because of the maintenance issues. So it is a lot easier to maintain these things. It provides the same, we think, we're still testing it, but provides close to the same sediment removal, and it's worked out really well for us. We're getting away from the vegetated inlets almost entirely, because when you're removing that sediment from that vegetated inlet, you're often changing the elevation. And as we talked about time and time again, inches make a difference. So if you're not maintaining them, the performance is impacted, and you should be installing these type things with maintenance in mind. Location is critical. You have to have access, and that may be design discussions prior to your involvement, but you can always bring that up to a consultant. You can always talk to the people that maintain these things. Hey, are you good with this? Is this, can you get your piece of equipment in? What does your equipment look like? As a project manager in your municipality, you should know the capabilities of your personnel and your equipment, so that you build things that they can maintain. So,
Brian, if I could interject, I will also note that in the case of a hard bottom, whether that's a paver or an aggregate concrete, it's a lot easier for the maintenance crews to know when they've hit bottom, which is not the case when you have a vegetated bottom. They just don't know where to stop. They don't know necessarily that they've gotten back to the natural grade. So this is just visually easier for the long-term operation and maintenance to understand this is now we need to clean this out.
And
So,
Brian, they're not using leaf blowers to blow out the sand, right?
they are not. So what we do is, and you'll see the river rock on the top right photo here, and then you'll see the paver forebay. So if you look at this paver forebay, it's right next to the roadway. We call it a drive-by. They do a forebay drive-by. So they can see when the first amount of sediment's there. Typically, they can do it with a standard broom. We also use a power broom, and we power broom it, but we will take a little bit of the rice stone or quarter-inch stone that fills the voids between the pavers. Though that stone has to be redressed. We usually redress it a few times a year. One of the things, and it's great to have a stormwater playground over here at Roger Williams Park. We get to try out all these things and then look at their effectiveness. And Ryan Kopp is a big part of how they're performing, and our friends at UNH and URI. So on this bottom right, that's actually exposed aggregate paving. And our theory is that that vertical drop will allow the sediment, because of the volatility, to stay in that general area. We're also providing a longer area for it to make its way. And exposed aggregate has a little rougher face than a broom finish concrete. So we anticipate that that sediment is just going to find its way into those grooves, but again, can be removed very easily. So we'll let everybody know how that works.
Well, yeah, one last thing in the design of those sediment forebays, something to really consider, and it wasn't always possible just because of elevations of the drainage pipes, especially when we had a diversion manhole, and so we were dealing with whatever the natural elevation of the pipe was. But to the degree that we could, sediment forebays are always in. It's always handy when they're in an area that's very easy to access. So to the degree that we could, all of these sediment forebays are located adjacent to the roadway. One, easier to clean out, but two, easier to see that they need to be cleaned out. When they're down a hill on the bottom of the slope, I think that's where the potential exists that they don't get the clean out, and then eventually they silt in, and eventually you don't have the treatment that was designed.
Thank you, Chris. So as a project manager, you are familiar with riprap stone as an inlet now. You're familiar with either granite or whatever's aware, but you've got to know that there's different ways to do this. So as we develop stormwater practices and the engineers do, they're making changes. So they may not be as obvious. So if you look at this middle picture, maybe tough to see, but this is just a line of boulders. So this may be, on the top left, may be your standard wear with a notch, but it doesn't look the same as this one. What is it doing? It's trapping the sediment. So this is a wood wear. And if you're a municipality on this training today, you know, I was a contractor here and I went out and bought wood after I advised the owner that your DPW yard has stacks of granite curbing that would be far better in this practice than this wood. We proceeded with the wood anyway, per their direction. But there's also Gabion baskets. This is a wear. This is a basket that has a vegetated top with stone in it, and traps the sediment at the front face of that wear, and then the water makes its way to the basin. So you've got to be able to identify where the wears are. This is a granite wear in this middle bottom picture with a spreader bar. So there was a lot of water coming in here. We wanted to make this hit this and make sure that sediment drops into this stone and goes either way. This is a better picture of the boulder wear. That does not look like this granite wear. This is a wear. It functions the same way. So don't always look about what you're anticipating it's going to look like. Look at how it functions. So during your construction, you want to avoid contamination of the assembly. So this is filter fabric. And again, we're getting away from filter fabric in some of these elements, but this is over a paver assembly. So this filter fabric is contaminated with loam. This is not acceptable. You know, this will grow weeds, it'll do whatever. So you got to make sure your contractor is really segregating his materials so they're not contaminating one with another. On the top right, we look at, again, a boulder wear wall, but this is actually a terraced wet swale. So there's an overflow here, but the water never makes its way to the overflow because the water is running past these boulders. So mortaring in between the boulders is something we had to do. You want to make sure that your water is getting through your Gabion basket, through your wear point. We install boulders here. And know that the sediment removal is not always at the front of the structure. This is a wet vegetated swale on the bottom right. There is a small riprap area on the inlet at the top of this function, but this is trapping the sediment, and there's a granite wear embedded this as well before it makes its final waterway. So know what they look like. It's not always the same. As we develop these practices, these things are going to change. So we went to pavers, and some of the lessons on that, which you may not be doing, we suggest you do it. We've had a lot of luck with it, but the edging needs to be used so it can keep the water on that forebay. You got to keep it in, whether it's riprap, whether it's rock, whether it's pavers, you have to make sure the water is staying on there so that that sediment drops down into the whatever it is, and so that it's not eroding the areas adjacent to it. From this top picture, you know, the pavers aren't just in this small inlet area. The pavers are going to extend up this 6-foot transition so that in a larger event, as the water makes its way up this transition, it's staying on the pavers. We find that as far as wears are concerned, the granite curbing is the best one. You got to make sure you put the curb block in it, set it in concrete so it doesn't move on you, because it's a constant flow of water, and water can do damage. The gabion baskets are done well with their vegetated top. It looks like grass, so our mowers now mow right over it. It's not always the intent to mow over these things, so low mow grasses could be installed on these gabion baskets as well. So the 4-bay walls, if you look at this top picture, you will see that the water is making its way past this weir. So the steeper the slope, the more you can contain. And design standards have typically been 3-to-1 slopes. We find that the maintenance is too much for a 3-to-1 slope. So we have now suggested a maximum 4-to-1 slope. But what that does is it allows water to make its way past the weir. So you have to provide some way to force the water through the weir. And it's difficult to maintain the vegetation, which is a part of the erosion control, if you can't mow it, if you can't trim it. So there's a middle ground there. And then during construction, on the bottom left photo, you'll see that real steep slopes in this stormwater element. One moderate storm collapsed them all, and the gabion basket had to be taken out, and we had to redo it. But you can utilize boulders to extend weirs into the slope, and then you don't have to make those slopes as critical. But double the number of staples on the erosion control fabric on those slopes, and it'll keep them in place. Infiltration basins and overflow. So we have now talked about getting sediment out. Now we're moving into the infiltration basins. So it filters pre-treated water. It's vegetated. Sometimes it has plants, sometimes it has grass. If your water is getting out of that infiltration basin, dispersing or infiltrating within 2 to 3 days, you're looking good. If it's there for 4, 5, 6 days, you've got a compaction issue. You've got to make sure that you take care of that compaction issue, because it allows the water to flow into the groundwater and then filter naturally to whatever and make its way to whatever waterway it's going to. Inches make a difference. They make a difference on overflow too. If your overflow is set too low, you're not getting the full benefit of the structure. If it's set too high, the water could be going over berms and ending up in other areas, which will cause erosion. So it's critical that they are set at the right height. They can be sticking out of the middle of a basin 4 or 5 inches, or they can be incorporated into a berm. And when we're talking about weirs, top picture, top right, you'll see, you know, don't be afraid to put a little splash into your weir, no pun intended. But art is a part of all of our construction projects, and don't be afraid to utilize it when you can. Infiltration basin overflows, 2 to 3 days. It's got to be out of there. The top right picture, this is a project that Heather was on, and this is probably a week or more old, and maybe this water never goes away, but you need to look at that and make sure you've done it, and then take care of it before you get mosquitoes coming in. You get all sorts of situations with cyanobacteria and stagnant water areas, so it's critical. Bottom left shows you a grate on a berm, and the bottom right shows you an atrium grate. So there's 2 basic kinds of grates. Atrium means it's arched, and the other basin is your standard flat basin. So the arch basin takes longer to get clogged because the water has to go up higher on it. But if it's in an area where there's pedestrians walking, it's not the best solution. So you got to be careful of that. And some of these are design things, but you as a project manager may not be involved in the design, but it's not outside of your purview to make suggestions to the designer during construction and change some of these things that may become an issue. So the subgrade in the basins, test pits before you put your material in, avoid compaction, don't stockpile materials here. They should remain clear. Sheet flows, instead of a pipe, overflows can also sheet flow. And we see this where you'll have areas, infiltration basin right along the curb line where water comes in, flows through, in high flow, it flows back out again onto the street. And that's an effective overflow. It rarely clogs. It's always working in high event storms. So don't be afraid to use riprap as an overflow or suggest it if you're on a site where you think it may work. So planting, seed, and erosion. This is usually the final part of our structure, and there's different schools of thought. I'm going to ask Chris to weigh in on plants versus grass for contaminant removal. Chris?
Yes, there's a lot of schools of thought about the types of plants that are best in the bottom of an infiltration or bioretention practice. I think there are certain shrubs that tend to clog the infiltration capabilities. Maintenance is another consideration, but probably most importantly is the soil beneath the whatever plant material is going in. This goes back to Brian's original getting your slips on the product that's being delivered and making sure that what has been spec'd, the engineer reviews the shop drawing, so we will get that slip that shows that yes, it's got the right mix, whether that if it's a sand filter, whether it's the right type of sand, if it's a bioretention practice, that it's that it has the various constituents that are required. Then it comes to the site and maybe it's not what they sent you on the slip, as Brian said. So ensuring that at least it's coming from the same place where they gave you the testing results, but also as the owner, in Brian's case, very hands-on, always taking pictures, always at the practices as they're being constructed. That's great. That's not always what happens, but you should have your consulting engineer or landscape architect view these sites as this material is going in. You can do a visual inspection. You can pretty much tell. We're used to it. We've seen a lot of these practices in making sure that the material going in is the proper material. If you don't have enough organics, no matter what plant material you use, you're not going to get good vegetative cover. And the combination of the vegetation and the soil below are the two that in tandem provide the contaminant removal that has been designed.
And it's directly related to maintenance. And Elisa, do you have any comments on the maintenance part of this?
Yeah, so, the soils and the planting, a lot of times DOT, we're just specifying grass because, the DOT's maintenance capability is whack, vac, and mow. So we're pushing designers towards designing things that could be maintained with a weed whacker, with a mower, or a vac truck. We've seen recently that the amended soils or the organics the loam has been removed from projects, and then they hydroseed over that, and it's not, and then the grass doesn't grow, and this stormwater system becomes all silted in from soils that never got established. So it is incredibly critical. That's not just an item you can remove from the quantities, to save some money. It has to be, that's a critical part of the water quality treatment of this. And Chris, I think you're going to talk about erosion fabrics.
This is something that we experienced at Roger Williams Park. Brian alluded to a little bit. So there's a certain proper way for the erosion control fabrics where we're expecting velocities to occur. So a 3-to-1 slope is a good 3 to 1 or greater slope is an example of where you're either going to need some sort of riprap or boulder protection or a long-term erosion control fabric. And the manufacturer's requirement is that material where the water is entering is embedded in the soil. And that means that the water flows over the erosion control fabric as opposed to under it. And what we found over and over again in Roger Williams Park is they're just laid at the surface, and then naturally the water flows under it and erodes the soil below the fabric. So it doesn't work in the first place. So proper installation, proper embedment, proper stapling, as Brian mentioned, extra staples, that's all very important. But the other side of it, which Brian has experienced, is in areas where you do plan to mow, sometimes what happens is if they're not well stapled down, as the vegetation begins to grow in, it pushes the fabric up. And the netting, in this case, we had permanent netting. It's a kind of a plastic type material. It gets caught in mowers. So watching that you use the right fabric in the right location, biodegradable versus non-biodegradable. So it depends on whether you anticipate water going over an area constantly. So where you see areas in the park where you see permanent slope erosion, that's an area where you would need a permanent, a non-biodegradable material. Did we lose Brian? I think we lost Brian.
I will look into what happened to Brian. I would suggest maybe we cover a couple questions in the meantime.
Yep, I can go. I've got some questions here that people have been putting into the chat. So the first one is about the gabion baskets and whether or not they rust and rot out over time.
I hate to date myself, but I've been using gabion baskets for probably 20 years. And I've never seen them rust to a point of degrading. I suppose maybe eventually I will. That'll be a sad day. I've gotten so old that my gabions have disintegrated. But I think even if the gabions were to disintegrate, they're filled with stone, and I think the stone would stay in place, and there's enough protection surrounding it that I don't think the loss of the gabion material itself would be an obstruction to the practice functioning.
And Chris, how do you maintain something like that? Do you pull it out and replace it, or the gabions?
If it really silted in, and again, I've actually never seen a gabion completely silt in. There's quite a bit of voids, and you know typically you have a 2 to 3 foot high stone layer, and so the goal of the sediment forebay is to hold back the water. The reason why I like to use the gabions is because I don't like the water to settle and stay in the sediment forebay. I want it to drain dry. And so if you do get some siltation in the bottom of the gabions and you start to see water standing and not draining out, you can always jet the gabions. You can jet the water through. You just need a little bit, but typically I haven't actually seen where they have failed. If you did feel that they failed, the baskets are just like kind of, you have a cover, you can lift the cover off and you can remove the stone, and you could jet it out that way as well if you couldn't get into the middle of the gabions.
Okay, I have another question here. It says, are there quality control protocols for engineered materials such as a bioretention soil mix?
Yeah, all of those materials need to meet the Rhode Island Stormwater Manual or the RIDOT linear manual, and that is one of the bioretention mix in particular needs to be tested and approved as it has, it have the proper composition. It can't have more than like 2% clay, and it has to have the right amount of phosphorus, not too much, not too little, potassium, other things. So it's critical that that soils get tested. The job that we did, it took a couple of rounds of finding the right mix. Just on the recent job we had, and but it's working perfectly. So it really makes a big difference. Nice to see you back, Brian. Well, can't hear you though.
Can you see my screen? Tess, could you send me a request to share my screen?
I believe you're still sharing.
Can you see that?
Yeah, we can see you.
And you can see the screen, my screen? We're good?
So did you change slides? Good, Brian.
Sorry about that, folks.
Try resharing now. While we're getting this back up and running, maybe we can cover another one of our polls.
Sure, I also have more questions that I can
yeah.
go through too. Okay, this one says, what would you say if you had to choose just one thing as the most important thing to keep in mind when overseeing construction of a stormwater BMP? What would that be? And if each panelist could maybe give their answer based on experiences that they've had in the field.
I can jump in first. What we've seen is that many times if things were caught earlier on in the process, it would be a very big time saver and money saver, really, because a lot of the times we only see things from our office at the very end of the project, final inspections. And at that point, everything's covered over and you have to do a lot more investigating to figure out, if something's not functioning, what is causing it to not function. And we always ask for as-built or construction plans to see how it was done. But by then, sometimes it's too late. And, you've spent all this time and money constructing something where you're not getting the results that you were hoping for. So I think that theme has been discussed throughout, just the, oversight from the beginning to the end, and never being afraid to ask questions. I would say that to all of our staff. So if you don't understand something, just ask. It's better than, ending up with a product that it's not very useful at the end.
I will say that I think the singularly most important thing is managing sediment transport, not into the sediment forebay as much as into the final practice, whether that's a bioretention or infiltration practice or a sand filter. The goal is to get the water into the ground and not sitting on the top. So protecting those areas from sediment transport, from compaction, from having the contractor drive over what's intended to be an infiltration practice and losing the permeability of the surface. And I see it over and over again where the sediment fills into the infiltration practice, and then the contractors are really not happy that they now have to over excavate the area, scarify the surface, bring in new material, and start all over again. And it happens over and over again. So I think protecting that final cell, or what was the third in Elisa's original slides, first the inlet, then the sediment forebay, then the practice. Protecting that practice at all costs is, I think, for me, the most important aspect.
And for me, I would say it's that every quarter of an inch is critical when it comes to flow diversion and getting water into the practice at all. You can build this practice perfectly, keep it safe, and then if you get the diversion weir messed up, or they didn't put in, or the elevations of the overflow or the elevations of the inflow, the water doesn't lie. It's got to get into the practice. We've seen a lot of situations where water doesn't flow uphill, and or the diversion is done improperly. Every inch counts.
Can you see my screen again?
We can, but you're going to need to go to display settings and swap your screens again.
Can we see it there?
Perfect.
We got it. We want to continue. I know we lost some time. We can just talk about plantings real quick. There are plantings that filter, and then there are plantings that blend your stormwater element into your site. So we oftentimes
I think we may have lost some sound from Brian. Yep, if you just unmute, I think you'd be good. Uh-oh.
I'll go back to,
Unmute.
I've got a few more questions, unless Elisa, Chris, or Heather are able to finish the presentation. I'm not sure.
This is a very unusual use of the mute button. We don't mean to mute you, Brian, at all, trust me. Chris, could you talk about the erosion fabric? Because you were talking about that before.
Yeah, I mean, I think what Brian is showing here in the upper slide is the incomplete coverage of the seed mix. And this is a lawn area that's just supposed to be grass at the end of the day once the practice was done. And, you know, you have some spotty application there and you're not going to get good grass growing. The picture at the right, that's actually proper installation. You can see where the hose is really aiming straight down, and that helps to embed the seed into the ground and gives it a much better chance to grow. And the bottom, I'm not really sure what what the intent was there, but I think I see some straw at the surface, and that really helps to hold the seed down and helps to establish vegetation.
Can you hear me now?
Yeah, there you are.
Okay, so that's exactly right. I spent a couple of years on a hydro seeder machine on the top right, and that the seed needs to embed itself into the soil. So if you see the tower being used on a hydro seed machine and the seed and fertilizer and mulch is raining down, you're not getting that seed embedding itself in the soil. The other thing is, a lot of times we'll have 2 or 3 different seed mixes in these stormwater sites in, call it, 100,000 square foot area. The best method to use is to have your contractor seed by hand the seed into the specific areas that seed's required, and then install the hydromulch and fertilizer over all 3, 4 different types of seed. That's the only way that you're not going to contaminate this hydro seeder with different seeds and getting that seed mixed throughout. So hand seed, rake it in like you would normal, hydro seed and fertilizer, hydromulch and fertilizer over the top. Another important thing about the seeding is timing. So if you're pushing that June 15th timing, you're going to get broadleaf weeds. And as Chris had talked about, the erosion control fabric has very small holes that grass seed, which is very narrow, will make its way through and embed that fabric. If you get broadleaf weeds coming up underneath it, it's going to push that fabric up. So double the staples in the inlet itself, and to make sure you get full contact when the water starts running, you'll get what we have on that bottom right-hand screen. So that's what you want to see, the grass growing through it. And oftentimes we'll see that filter fabric up above the soil layer because it's being pushed up by weeds or whatever else is there. So planting's very, very important. 99% of the times, plantings are installed too low. So the way trees are grown in nurseries, they get moved several times. There's a root crown, and look it up, go on the internet, look at a root crown. The root crown should be above grade. So rule of thumb is you should not have any loom on top of your root ball, because that tree has been planted 3 or 4 times, moved to 3 or 4 different fields, and planting a tree too low is the biggest reason for it dying. We talked a little bit about mulch. We do not mulch plant material in basins because that mulch becomes a floatable object, which will clog up your sediment controls. So we want to keep the mulch out of the basin, but certainly it provides some moisture for the plant material so that they'll grow and survive in the earliest days that they need to. Again, if you're going to push that June 15th date, which is the Rhode Island DOT date for seeding, and you have erosion control fabric, you're going to be dealing with broadleaf weeds. So you want to make sure you get that done before that, because it's difficult to get them out once they're underneath that blanket. And then you're too late in the season to get it done. The last thing is protection. So on the left-hand side, you'll see that there's tire tracks that have gone over this newly seeded area. So you want to keep pedestrians, you want to do whatever you need to do to keep people from walking on the new seed, if at all possible. And then there are special cases. This is on the right-hand side, a park that had wetland plantings right along the shoreline with an extremely fast running current. So we took the extra precautions and installed these very large sandbags and left them in place for about 3 months. And the reality was we did get some erosion right along the silt sock. The water came in and it took it out. So when it was time to remove those sandbags, we just opened them up and put the sand into the void that was created by those tides. So you may have to do special protection to get your practice to grow in so that it becomes effective. So I know we've already took some questions, but that's the end of the presentation. So I don't know if you want to go back to the questions, and I apologize for being tossed off by whomever, whatever. So thank you.
Yeah, sure. We have a few more questions here. This one is about maintenance of paver forebays, asking how you are maintaining them. And then the follow-up question is, have you done any infiltration tests to make sure the spaces between the pavers aren't clogged?
So I'll go first if you don't mind. So the paver forebays allow you to see when sediment's collecting immediately. So, and then, it's easy practice for our crews to stop and just take it, because it takes them literally 5 minutes. So I think having your crews go out and do maintenance once every month or every couple of weeks when it takes them 5 minutes is a much better practice for us anyway than having them once a year remove all the river rock, wash them down, remove all the sediment, put all the rocks back in. They just don't want to hear it. It's too labor intensive. So for us, it's been fine. We do need to use a power broom at times to take that rice stone out from underneath the joints in the pavers, and then you just hand dress it over and put it right back in again. It's simple. Our guys have told us that it's night and day compared to what they used to do.
And really, the only reason, depending on your gabion setup or depending on your weir setup, the only reason that the pavers are supposed to be permeable, so it just goes back to the why. How is this functioning? It's just to make sure that water doesn't stay in the forebay longer than 2 or 3 days and breed mosquitoes, that it fully empties. So, a broom might be just enough for that example where there's the gabion weir, because that's it's level and the water's just going to drain out through the gabion. It doesn't have to go through that permeable paver. And that doesn't really even count towards stormwater credit, so to speak. So it's very different than when you're putting a permeable paver in for the sake of having that be permeable as a stormwater credit. If you're putting in a permeable walkway or a permeable patio or something like that. Just using it as a sediment forebay is really for the maintenance of it. And depending on how your weir is, asking that question, it doesn't necessarily have to always be permeable.
Yeah, I was gonna mention that the sediment forebay, as a design engineer, we know that's where all of the sediment is going to get to first. I anticipate that is going to get silted in. I'm not particularly worried about that having any kind of infiltration capabilities. If it does, that's a bonus. It ensures that it stays dry. But this is why, for me, it's important that the weir you can see some of the pictures that Brian showed. There may be a notch, but there's also some, in some cases we have stone or the gabion basket, so the water can flow through and drain dry, not hold water. If the sediment forebay is designed where the weir does not allow the water to drain out completely, then it most definitely has to infiltrate. And I think that's an impossible situation given that it's going to continually get sediment into it, which is its function. If after the sediment forebay, as Elisa said, you have pavers is your infiltration practice, then those do need to stay and have sufficiently large voids between the pavers. Or we did use, actually the paver material was porous in this case. And we used a variety, but in this case we did use an actual porous paver, so the voids in between are not as important as a solid paver. But again, we're just trying these things out. But it's as a sediment forebay practice, which is the only way we use them here, and on the pictures that Brian showed at the park, they're all sediment forebays, so they're all anticipated to eventually probably silt in.
And the follow-up question was about doing testing and At the moment, we are not doing infiltration testing in the forebays on the pavers, but we are looking into getting some instrumentation from University of New Hampshire that will be able to test that. Here's another question. It says, what are the key oversight stages during construction of bioretention?
I think I'll take that first. So I think the subbase, you have to make sure that before material is being brought in, that subbase is not compacted. We've said 1,000 times, that's critical. And you typically, we do weekly meetings, but if you're not going to your site every other day, you're missing a lot if there's a contractor actively working on it, you know. And in particular, I would get there when there's storms. During a storm, right after a storm, those are the critical times. When it comes to stormwater projects, that's when you see what's going on.
Okay, this is another kind of maintenance question, but it says, what is the best method to clean the through walkway inlets that once they get clogged, that it looks like a pretty tight space and not real easy to get at?
So we do a lot of graffiti removal, and so our power washer, we have a large power washer on a trailer that's going out, you know, 2-3 times a week. So we're starting to utilize that as a way on those real narrow 10-inch trench drains through the sidewalks. We blow them out with a power washer. Typically, we'll blow them towards the street, take the debris out, so we're not pushing it into the forebay. But you can use a power washer. You can use, if it's big enough, you can just use a broom or anything else. But yeah, power washers worked out well for us on the smaller ones.
But they also have a bolt on the top, and if it really got clogged and the power washing didn't work, you could just open them up and brush them out, shovel them out, and put the grates back down.
Yeah, Brian, can you show that grate on the top? You mentioned something about the concrete or the cement to hold it in place. What was that? I don't know if that's too much, but.
So when we put those trench drains in, or I call it a trench drain, it's a sidewalk drain. We had one where the end of the metal grate was exposed. So you could literally go over and just pick the middle grate up if you took the 2 bolts out that hold it down. So what we ended up doing was carrying the concrete around the back side of it. So all the sides of that drain were fully encompassed in concrete, and it's more difficult for you to get it out if that's the case. I've seen this, you know, there's all sorts of versions of this. I see everywhere I go. I've seen plates just dropped in and resting on concrete with really no mechanical attachment whatsoever. They're never in the same place. People move them. They're on a sidewalk. They become a trip hazard. I've seen these more often. I've seen them done wrong than I've seen them done right. And you know, at dusk, you can't see it. You walk over it, you're falling. It's a trip hazard. So this is the photo. Bottom left, you'll see that there's concrete that encompasses the entire drain. The photo on the right, this drain goes all the way and daylight's at the end. So there is a void that's created underneath the concrete over here, so the water flows out. Obviously, this one is just open at the end. So vandalism and potential movement should always be a consideration.
Okay, one more question here is about the specific erosion control material called Kerlex, and saying that it contains nylon netting, which I guess is not ideal. And so this person is wondering if there are good alternatives that you guys have used instead of Kerlex. Yeah,
there's a company called North American Green. They have a multitude of erosion blankets based on velocity and an amount of water that's running over it. We have a rule of thumb. If we are going to, so there's biodegradable and non-biodegradable, and there's different times that it takes for these meshes to biodegrade or degrade. So if we are going to put a fabric in an area that we're going to mow regularly, we want a fully biodegradable fabric so that that mesh doesn't get caught up. You've probably seen it sometimes. It's like a fishing line, a mesh fishing line that gets caught in a mower. It's not safe. It's unsightly. So if we have an area that we will never mow or weed whack once a year, we'll do a more permanent fabric because it does assist in holding the vegetation. But in areas that we're going to mow within 6 months, we want something that's not going to be there anymore, which could be a standard jute mesh too. But North American Green has a lot of products that you could look at.
Anybody else have any input on the panel? Okay, I don't think we've taken our last poll. Why don't we go do that? Can you pull that up, Tess? Thank you.
And just to let folks know, you can click more than one option for this poll. I'm seeing that about 40% of folks have submitted a response. I'm going to give it, I think, Ryan, just 3 more seconds, and then I'll share the results with everyone. So I'm going to close the poll in 3, 2, and 1.
Okay. All right, that gives us some ideas of future trainings that we can hold. So thank you very much on that. Here's
We wanted this one in the field, right, Brian?
What's that?
We wanted this training to be in the field.
Yeah, I think that, there's a lot of information to cover in 2 hours. Here at the Stormwater Center, we could do a classroom for half a day and then walk out into some of these sites and talk about what we learned about. I think that would be valuable if you're a project manager, or even if you're one of my counterparts in a municipality and you maybe have just gotten a consent decree. There was a big learning curve for most DPW directors or parks personnel in stormwater. It's not something they used to be being involved in. I was a contractor, so I had more experience in it, but I wouldn't even know where to start if I didn't have the experience. Like, I knew engineers from when I was a contractor and I reached out to them. So there's a much bigger training, soup to nuts. You need to start putting in stormwater. What do I do? All the way through, how do you close it out? And we'd love to give that training.
Okay, and here's another question. It says, is there a precedent for using the stormwater system location as a temporary sedimentation control for construction? And it says often contractors build stormwater facilities first and then have to diligently protect them for the duration of the construction process. Are there considerations for construction stormwater controls last? It's a long one.
I think there's some element of dewatering operations that may need to happen, and you can get very specific on dewatering. There's cofferdams, there's all sorts of construction practices that can be utilized to keep water from entering a structure. I find that if you can, like we said before, if you can keep the existing infrastructure in, which basically a catch basin in the road is an overflow. The water goes into it, it pipes to the waterway. So that is an overflow. So any catch basin you can use as an overflow. So sandbagging didn't work for us. So in other words, you're taking that catch basin offline. There's a pipe that comes out. If that pipe is 8 to 10 feet down, you can build that stormwater structure over that pipe and then plug it at the end. That's the perfect situation. Once it's grown in, you let it flow back again. So that's perfect. But oftentimes the elevation of the pipe becomes the elevation of the stormwater element. So you're digging past the elevation of that pipe, so you can't leave it in place. But leaving that overflow pipe in place is the best scenario.
I also I kind of heard that question a little bit differently too. Maybe I can answer it this way as well. Temporary stormwater basins during construction, they're called sediment basins, really shouldn't be utilized unless you have over 5 acres of contribution of an open site, open dirt, basically an open site heading towards it. If you have less than 5 acres, you should be able to contain and control the stormwater maybe with some small sediment traps, but not a sediment basin. So rarely in Rhode Island are we exposing more than 5 acres at a time, maybe for a landfill cover or something like that. So I would highly, highly, highly discourage using a stormwater system unit as a temporary basin. You should be able to do what you need to do without creating a temporary basin. Rarely, occasionally, we've had to do that. And if you do that, and if you do have to work that way, then you'll have to completely reestablish the infiltration capacity of that basin after the construction is over and before you put water into it. So you'll have to redig it out, scarify, reestablish infiltration, and then establish the seeding and establish the soils around it.
Yeah, I would add that, you know, in a lot of cases, we do install sediment traps and sediment basins up gradient of our practice. At Roger Williams Park, a lot of these photographs, this is very tight, tight construction. It's adjacent to the road. Disturbance of a historic park that's intact. In order to put in some of these sediment traps, you would have to disturb more of the park to do it. And so, as Elise said, where you can, not having to put those in is in this situation is beneficial, but certainly on larger projects. I'm currently working on a solar project that solar projects are the worst because you're opening up a phenomenal amount of area at one given time, and sediment traps and sediment basins are absolutely required in those situations.
Okay, we've got a couple more late questions coming in. It says, are there other forms of slope stabilization that you would recommend to prevent erosion, such as infiltration trenches, berms, or terracing for areas with steep slopes?
One of the more easier, traditionally more used is riprap. You can riprap the slope, just place the riprap stones on the slope itself. That's going to hold it in place. That's one of the easiest.
We're trying something interesting. We did have an area where it wasn't really a stormwater practice, but we were trying to control erosion. And in lieu of using riprap or an erosion control fabric, what we're doing in that case is we've actually sort of cut into the slope and installed a 1.5 foot high living wall practice. That's a Filtrex practice. And so we are creating that terracing down the slope. We're hoping that the combination of leaving the vegetation unmowed across the Filtrex sock, you know, the so-called living wall, will dissipate velocity. And then of course the drop, the 1.5 foot or so drop will also dissipate velocity. So it levels out the grade between the living walls, that slows velocity, and then the drop will also help. The drop in the vegetation should help. So that's actually something we're trying out at the park.
Okay, then we have one more. It says, how is everyone capturing their inspection forms? Are you utilizing an electronic system such as a GIS-based Survey 123?
So we use Survey 123. So Survey 123 is awesome. So it's a software program called Green Cities, but I believe any GIS Esri product will suffice. Survey 123 pops up on an iPad, which all of our crews have now. It shows you the structure, and we did a big training with our crews and with other municipalities with pictures versus text. You know, O&M manuals, operation and maintenance manuals come, and they're 3 inches thick. There's thousands of pages, and nobody's reading them. So we put pictures. We use pictures of the plants that they should look like, and then there's that checklist of 15 or 18 items that you've got to look at. Is there sediment in the inlet? You know, they check it off. That automatically or electronically gets sent to the director. The director then logs that. It's a requirement of our consent agreement. So we had to do that, but we have now used it on all aspects of our maintenance, playgrounds and otherwise. Survey 123 is a great software to use. If you haven't looked at it, you should.
Our office also has utilized an app called iAuditor, and we use that in the field for SWIP inspection audits, for our final inspections, for our overall environmental compliance inspections, it's very similar to Survey 123, but we started using that and that has helped us a lot.
And if those products can generate a work order, if it's a manager or a foreman that's going out, or it can be your rank and file that actually goes out, pulls up the picture of the inlet, checks the boxes, and then forwards it. So it can be used on both sides. If I see sediment in a basin for more than a couple weeks, I'll shoot a Survey 123 and create a work order, and then they go out and do it.
Okay, that seems to be all the questions that we have in the chat. So I'm getting close to being out of time. A few more minutes here.
I'll just add, Ryan, that for anyone wanting to follow up on the training or review the recording, that, like we mentioned at the beginning, it will be available via both the SNEP Network website and the PSIC website, and the links to those will be in the follow-up email that you receive. And additionally, you are welcome to request a certificate of attendance for today. We can't guarantee it'll be accepted by whatever your licensing agency or professional development organization is, but we're happy to provide one if you just respond to our follow-up email with a request.
Okay. Yeah, I think that probably puts a wrap on I don't see any more questions coming in, so.
Well, thank you.
Yeah, thank you, everybody. Thank you, all the presenters, for doing a great job, and thank you, everybody, for attending.
Yes.
Thank you.
Thanks.